Good afternoon, sir. Good afternoon, classmates. The topic is all about Mar's theory of perception. So, perception is how you interpret the world around you and make you sense of it in your brain. You do so via stimuli that affect your different senses: sight, hearing, touch, smell, and taste. How you combine these senses also makes a difference. We take in information through all five of our senses, but our perceptual field, the world around us, includes so many stimuli that it is impossible for our brains to process and make sense of it all. It involves both recognizing environmental stimuli and actions in response to this stimuli. Through the perceptual process, we gain information about the properties and elements of the environment that are critical to our survival. Perception not only creates our experience of the world around us, it allows us to act within our environment. Some of the main types of perception includes vision, touch, sound, taste, and smell. And there are also other senses that allow us to perceive things such as balance, time, body, body position, acceleration, and the perception of internal states. Many of these are multimodal and involve more than one sensory modality. Social perception, or the ability to identify and use social cues about people and relationships, is another important type of perception. Through the perceptual process, we gain information about properties and elements of the environment that are critical to our survival. So, perception not only creates our experience of the world around us, it allows us to act within our environment. So, how does it work? The perceptual process is a sequence of steps that begins with the environment and leads to our perception of a stimulus and action in response to the stimulus. It occurs continuously, but you do not spend a great deal of time thinking about the actual process that occurs when you perceive the many stimuli that surround you at any given moment. So Mar emphasized that vision was nothing more than an information processing task. Any such task, he argued, could be described on three levels. So one is computational theory, and two is algorithms, and three is physical implementation. The three levels correspond defining roughly to defining the problem and setting out how in principle it can be solved. And two is designing a detailed simulation of the process. And three, building a working system that will carry it out. The important point is that the levels can be considered independently. As a result, it ought to be possible to mimic the algorithms underlying biological vision in robots. The only difference would be in how they are implemented physically. This concept of independent levels of explanation remains a mantra of vision research. Marr attempted to set out a computational theory for vision as a whole. He suggested that visual processing passes through a series of stages, each corresponding to a different presentation, from retinal image to 3D model representation of objects. One problem with this account is that information needs to be passed continually from one coordinate from to another. There is increasing interest in models that avoid coordinate transformation of this kind, rather using information stored in retinal coordinates for tasks such as object recognition or navigation. An example of this is the bottom-up perception processing. How bottom-up processing works. So the theory of bottom-up processing was introduced by psychologist E.J. Gibson, who took a direct approach to the understanding of perception rather than being dependent upon learning and context. Gibson felt that perception was a what you see is what you get process. He argued that sensation and perception are the same things because Gibson's theory suggests that processing can be understood solely in terms of environmental stimuli. It's something referred to as the ecological theory of perception. Bottom-up processing works like this. We experience sensory information about the world around us, such as light levels from our environment, and these signals are brought to the retina. Transduction transforms. Electrical impulses travel along visual pathways to the brain, where they enter the visual cortex and are processed to form our visual experience. And this approach to understanding perception is an example of reductionism. Rather than looking at perception more holistically, including how sensory information visual processes and expectations contribute to how we see the world. Bottom-up processing breaks the process down into its most basic elements. To process and understand a text with bottom-up processing, we start by recognizing phenomemes, combining this into syllables, syllables into words, words into clauses, and so on up to contextual and background information. There are two general processes involved in sensation and perception. Bottom-up processing refers to processing sensory information as it is coming in. In other words, If I flash a random picture on the screen, your eyes detect the features your brain pieces it together, and you perceive a picture of an eagle that you see is based only on the sensory information coming in. Bottom up refers to the way it is built up from the smallest pieces of sensory information. And that's all. Thank you.